Okay, the counter is counting, the bytes are biting, and I can see myself on the screen. Welcome to another CodeZone. It's been a while, but it's the first one of 2025. It's very exciting, and we're going to be doing some more LivePixel stuff. I thought we would live code something tonight to do some coding in the CodeZone. But before we get going, we've got to play this, of course. Right, so completely unplanned CodeZone, a bit of a spur of the minute thing. I thought, you know what, I've got a bit of an hour of time to myself, I'm going to do a bit of programming. And tonight we're going to look at something that Danderstein and myself have been working on behind the scenes, sort of on the OLC Discord. And it's to do with WebSockets, which is going to feature a bit predominantly throughout the year, I think. I've got lots of little ideas to play with WebSockets. And in the previous CodeZone, we had a look at a pixel art display. In fact, if I press this button, we can see the said pixel art display, and we talked about how this was implemented and how it works. Now the good thing is I have got a display now where I can see other people in the chat. Look at that. So I can see Magetsub's here, congratulations. I can see Bixie's here. Nobody else is chatting at the moment, but good, at least this is working. Oh, B3, no, Ben Kid. Hey Ben, how you doing? Not seen you for a while. So here we can see the LivePixel display, which we've talked about, and I'm not going to go into the guts of that again. We do need to do a bit of a follow-up video to this to look at some of the server side things, and I will do in detail some other time, but I thought I'd show you this this technology that Danderstein and I have been working on. So I'm going to press this button. I'm going to try and get used to things again. There we go. So hopefully that should be my screen. There it is. Now you may notice something unusual, that I've actually got Visual Studio Code up and running, and that's because I'm using the remote development facility of Visual Studio Code. It's actually quite cool and works very well, particularly because my server is running a sort of a Linux distribution, and Visual Studio doesn't work quite as well. But I want to show you this header file. It's not for public consumption just yet. But it will be soon, and so myself and Danderstein have been sort of hacking together some things to make it work. And I wanted to create sort of a Pixel Game Engine-esque header utility for hosting WebSockets, in particular hosting secure WebSockets too, which I think just allows you to be a bit more professional with your applications. I'm not going to go into the details of it, but other than it is a class like the Pixel Game Engine where you derive a handful of functions. So for example, you can derive on-client connect, so when something connects to your WebSocket, you can go ahead and deal with it. What's the data that's coming in? What happens when we disconnect? On update is interesting, I'll come back to that one in a minute, and on validate incoming. There's also on HTTP. Now, this is a little bit experimental, but one of the things that this header file can do is also, it's not just a header file yet, but it will be. One of the things it can do is also serve HTTPS and HTTP requests, and that's quite useful because you can then actually serve the code which might want to communicate to your WebSocket. And on a desktop situation, if you, for example, you wanted to create a GUI in the web browser but actually have your application running in C++ on the back end, this allows you to do that. So you would just start the executable. Your executable could automatically launch the operating system's browser to a known location and then start dispensing files to it like an HTTP server. And that's, I found that quite a compelling way to start thinking about user interfaces. Anyway, press this button, go back to the code. Still learning how all of this works. One of the things I wanted to implement was the ability to sort of really monitor what the clients are doing. So I think it's important that we go to the LivePixel website. I'll drop this link in the chat because I know you've all sat and played with this before. If you go to this website, hang on. If you go here, you can start sort of colouring in the pixels in real time. And it changes for everybody that's looking. So nothing new here. We've talked about all of this before. I just want to make sure, I'm not clipping too much, am I? I'm just getting some sort of error bars appearing on one of my audio feeds, but I'm going to run with it anyway for the time being. LCOB32. I typically watch on YouTube. Oh, well, I have been streaming for a little bit, for a while. Oh, Kieran's here as well. Standard Int, hello. Oh, and Bogu. Bogu. Oh, there we go. Good. Somebody's at least logged on and colouring things in. Well, one of the things that the LivePixel application allows you to do behind the scenes, I'll go and have a look at the LivePixel code. This is the server code. So I override the WebSocket server file, and I'm really only bothered about one thing, and it's what the data's coming in. We look at it, and it validates the data, and then it echoes the data back out to everybody else, and it does something interesting. Whatever the data that was sent, if it was valid, it stores it in a history file. And the history file is not very exciting. It looks like this, which is just a bunch of hex, but there's a large number of them. And so this is every valid pixel that has been sent to the LivePixel display. I think somebody's having fun colouring the thing. So if I just switch over to this screen, I don't think you can see it because of the light. So I just turn those lights off. Might be a bit bright at the moment, but anyway, somebody seems to be colouring something in. So it is actually it's live on there too, as well as on the website. Now, I thought it would be interesting tonight to hack something together just in Pixel Game Engine to actually view these history changes and see how has the image changed over time, and then with a sort of a thought to, well, maybe making that part of the website as well. So there we go. That's all the history information we're going to take, and I'm going to sort of create a Pixel Game Engine application to sort of display this history and view it at different speeds. And it'll be a nice, interesting live coding session, something we don't typically do in the CodeZone. So I'm just looking at the chat. Right. Let's begin. Let's get Visual Studio going. So I'm not going to do it in Visual Studio Code because I'm going to do it sane. I've created a stub Pixel Game Engine application here just so we can get going with doing some code. And I'm even going to cheat a little bit because I'm going to create a new file, add a new item on here. Oh, hang on. Ooh, need to put the right screen on, don't I? There we go. Yeah. Need to create a new file which is going to just be a text file with all of that information. Now, of course, it makes sense to pull the history file live every time you want to view it, but I'm not doing that tonight. Tonight is keep it simple because it's quite late. I've had a long day, and I hurt myself running, for those that haven't noticed. Oh, and I should also point out, nobody's commented yet. I have new glasses. Look at that, like new glasses, because I sat on my old ones. Right. So I'm going to create a file called history.txt here. And I'm basically go from the Visual Studio environment from the Visual Code environment. Oh, I hate the fact that they call them the same things. I'm just going to copy all of that and deposit it in this file. There we go. So we can see that there's not been that many pixels has been set. About 1,500 pixels has been set during this particular instance of the server. And I know that some people have been hacking things and sending their own images. And certainly the previous instance of the server ran for about 5 weeks without any incidents. So unfortunately, that wasn't recording any history. I didn't do that at the time. Should have thought about that, but hey-ho, it is what it is. Thank you, Joseph. Thank you. Are they the same model of glasses? No, they're not. Unfortunately, I needed a new. I've not had new glasses in 10 years, so it's been quite a change. It's crazy. I can actually see, which surprised me. I thought my eyes weren't as bad as they were. So we're going to open up this file and we're going to read it line by line, and from that we're going to then sort of display the colours of the pixels, and we can have a look at the formatting of this hex. So I think this is not a challenging application at all, at least I say that. I hope it's not going to be a challenging application, and we can just see what people were drawing, get it to play it back automatically. I think I'm going to start by obviously loading the file. I think that's most important. Now we want to load in the entirety of the file. So I have to remember my old sort of C stuff here to do this. Let's bring in IF stream because we're going to be... you can tell I've been programming in a different language today, can't you? There we go. Oh, come on. Come on, fingers, wake up. iStream, isn't it? Oh, there we go. Yes, you see. And I want to open this. There we go. That's the IF stream, IFS. And we're going to open that in on user create. And all I'm going to do is open up the history file we've just created. So ifs.open history. Ooh, need some things, don't I? Oh, why has that gone back? So every time Visual Studio does an update, it seems to lose this particular setting, and I can never remember how to put it back. Right, I really hate this. I hate the fact that if I have something highlighted and I press either an open bracket or open quotes or something, it puts the whole thing in quotes. I find that really, really annoying. It's really annoying, and I'll tell you why I find it really annoying. And if Starfreak Clone is watching, whatever magic you can weave, make this go away. Like, let's say you have something like this. If x is less than 8, right? Something, just a bog standard if statement with an inequality in there. And you go, oh, hang on, I've got that the wrong way. Oh, that's really annoying. It's really annoying. And you go, oh, I don't want all that. I just want it to be an angle bracket. And it puts more in. And yeah, so somebody find out how to remedy that, please, and ping me on the Discord. I really hate it. Yeah, isn't it? It's really bad, Bixie. It's awful. Right, so anyway, yes, rant over. Open the history. I suppose we should check, did it actually... No, do you know what? I'm not doing any error checking today. I'm going to assume that it did that hunky-dory, no problem. Now, I don't want it to just sort of blast through all of the data in the file. I'm going to read the file sort of live, because could be, potentially these history files could be very, very large at some point. I don't want to have to read the whole thing into memory all the time. I can see that the text has changed on the display. I'll just quickly jump over to that. There we go. See, just to show you, it is live. You'll see I've managed to get my buttons a bit more coordinated now. So I have my Logitech thing down here. Where's my camera? This camera here, if you see this thing, this is actually in control now of the which display is on. I've got to remember which microphone's being used though. Right. So we've opened the file. Now what I'm going to do is I'm going to track time, really. And because I don't want it to just sort of immediately display everything on every frame. So we're going to, every time X number of milliseconds has passed or whatever, then we're going to sort of update a new pixel. So we need to accumulate time. F accumulated time. Right, so there's a classic pattern that we use quite a bit when we want something to happen periodically in Pixel Game Engine land. We can just accumulate F elapsed time. F accumulated time is equals F elapsed time, and if F accumulated time is greater than or equal to, what do we want it to be? Well, that speed might be something variable later on, but let's say for now we want to display something every 20 milliseconds or something, so that would be 0.02 in Pixel Game Engine speak. Now we don't just set F accumulated time back to 0, we subtract from it what our our check is, and that allows any sort of residual mess to not go missing, and it keeps the timing just a bit more accurate. So F accumulated time minus equals 0.02. Now we might come and try and make that variable later on, but let's just get it working first. Now if that's the case, obviously we want to update the latest pixel. So I'm going to just simply if ifs.eof is not, if we're not at the end of the file, read in the next line. Now, how do we read in the line? That's what I need to remember. ifs.getLine, it does, getLine, very good. And this takes in, it doesn't take in a standard string, does it? That's a pain. GetLine. I want the better GetLine. Is there not a better GetLine? Standard GetLine, which is this one. So if I put in IFS, is that better, and then pass in a string? Does that work? Let's have a look. Standard string, S-line. Is that the same? Does that work? I think that works. Make sure it's actually found that. I don't know where standard get line resides. What does that live in? It's compiling anyway. It's having a think. Well, it's running. May have to run the debugger a little bit on this to see if any of it's working. That's okay. So we get the line, and then we want to parse this line sensibly. Now, when we got the history, what we have here is a sequence. Let's go and find a more interesting number. So the first 2 digits are telling us the X and Y location of the pixel, and the last 3 digits tell us the most significant 4 bits of the colour that that pixel is going to be drawn with. So we want to read each character individually, and then we want to convert that hex into, well, whatever it means to the system. So let's do that. And you know what? I'm going to okay, so we want, certainly the first chart is the X location. So that's going to be S-line 0. Absolutely no checking going on here. The next character is the Y location. I think that was the case anyway. We'll find out if it's rotated 90 degrees if we've got that wrong. The next character is R. The next one is G. And the last one is B. Red, green, and blue. But they're coming in as hex, so we're going to need to convert those over to, well, to integers, I guess. And I'm going to do that really, really sloppily. I'm going to create a little lambda, and I'm going to do this entirely manually. Auto... what are we going? Hex to int. There we go. Hex to int equals whatever that is, and const jar c. And in there, I'm going to have a switch, which is going to switch the C. I know there's probably some nice like C++ functions to do this, but I'm going to do it manually. Right, let's have a look. Let's create some space. Don't know how many we've got there, but let's start with that many. Case, whatever. Oh, hang on, what we've opened up there. Case, hello. There we are. Case, whatever the character is going to be, and then return some number. We'll come back to the number in a minute. Right. So we know we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C. Oh, I've run out of a few. D, E, F. Right. A, B, C, D, E, F. Okay, good. And because I know that the system can actually tolerate both upper and lower case of these, that's what I'm going to do. 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 15, and we'll just duplicate these bottom ones. There we are. A, B, C, D, E, F. Perfect. It lives in string. There we go. Okay. Well, it's useful. It's strange that this thing just sort of exists. Right, so I've got a very, very hacked together hex to int of a single character to some meaningful number. That's good, good, good. Switch is done. Close the lambda. Okay, if the character is anything else, just going to return 0. Oh. Return 0. I'm missing some brackets somewhere, according to this. Is that right? I'm missing a bracket somewhere. Case, switch. It looks like I'm missing a bracket somewhere. Oh no, I wasn't. It's just Visual Studio being helpful as usual. Get line. Why have we got some red wigglies going on under here? So I must have a bracket missing somewhere. Yeah. Does look like it. So that one will be there. That one will be there. No. What's going on? What's going on? Where's my bracket missing? Switch. Cases. That's all fine. That's all fine. This one lines up there. This auto doing its own thing. Oh, it's popping out. Is it actually a problem? Compiling. It's thinking. No, it's not a problem. I don't know. I don't know why it's bitching at something. I don't know what it's bitching at. Morris, what's up? Gets up from Charles. Isn't there like standard from Charles? Yeah, probably. But I mean, I've done it now, haven't I? By the time you guys figured it out, it was coded. It's done. Ship it. It's done. So we've got a Lambda function which does this brutal sort of brute force conversion. Let's go and then do something interesting with that. So we know the X and Y, and we know the R, G, and B, so we just need to set the pixel. Now, I've set the pixel game engine up to be just 16 by 16 pixels, but each pixel is 48 by 48. So we're going to see really low resolution pixel game engine, but that's perfect. That's exactly what we need. So I'm going to draw a pixel at, hex to int x. Hex to int. Oh, thank you, Johnny G. Appreciate that as always. Hex to int y. And then we're going to specify the pixel. Now, got to remember, these are just 4 bits, and they represent the most significant bits of the colour. So hex to int r, but then we need to shift it like that. So that's red. Why my phone just went ping? Oh, I've had a body response. Sounds awkward, doesn't it? G and B. So the problem with wearing a smartwatch is it tells me all of these things. Perhaps I don't want to know. Right, so I've specified the pixel. That's very good. So that's going to draw something. Is that going to work? Is that enough? Is that our program? Is it done? Was it that simple? We can add some usability. I don't like this. I don't know what's going on there. It's throwing me that line. Right. So every 20 milliseconds, it's going to read the next line from the file, I hope. And then it's going to draw a pixel according to the history that it saw. Now, maybe 20 milliseconds might be far too fast, because that's 50 updates per second. It's running at about 60 hertz, so that's okay. And we know there's about 1500, so 50 updates, so that's 1 second, it's 2 seconds to do 100. So it's only going to be about 30 seconds to view the whole history thing. Now, disclaimer, I have no idea what people have been drawing in my absence, so whatever symbols and pictures may start to appear, it wasn't me. Frontmaster, good evening. I haven't seen you on here for a while. How often do you stream? Well, the plan actually is now to stream pretty much weekly. That's what I like to do. I've had a few weeks off over Christmas, but we've got the studio set up. In fact, I've a brand new guy here, first time channel, I'm assuming guy, that we've got the new studio up and running. I've got the sign, and I've got the tools, and I've got the 3D printer, and I've got the overhead camera view to do things with. So you can see somebody's already automatically spamming random colours at this. And that's one of the charms of a community project such as this. Let's go back to the code. And where is the website? What is it actually currently displaying at the moment? Ben. So one of the things, why was the display sort of showing this noise? That's because the display is nowhere near as quick at receiving the updates as the website is. If I reset the hardware, which I can do actually, if I reset this hardware, turn it off, and turn it back on again. There we go. once it's booted up, it will sort of find whatever the most recent is. So you can see that the actual delivery of pixels to the ESP, since we last spoke about this, I've done nothing to it. This is still running the same piece of code. So there's some optimization to be made there, I'm sure. Londo, hello. Yeah, oh, thank you, Joseph. Yeah, the the new studio is awesome. Hey, Morris. Yeah, if I know you might not actually be there, but I was doing some maths recently for a video. I did actually sort of. I was trawling through this, and I thought, oh dear me, I've no idea what's going on. So the viewers are going to have no idea what's going on. And I must confess, your distaste of mathematics did sort of pop into my mind. Anyway, so we'll come back to whatever that is in the future. That's some video I'm putting together at the moment. Refresh rate of 5 seconds per frame. Yeah, it's pretty bad, isn't it, on here? But it shouldn't really be playing whole frames. Now, one of the things, why have I... Let's just take a step back, because I noticed there's a few people in the chat that are asking interesting questions. Frontmaster, thank you very much. Appreciate that. So if I go back to the Visual Studio Code thing, so this thing that we've been working on to sort of make using WebSockets trivial has a lot of sort of anti-cheat features bundled into it. Now, at the moment, I've not got them enabled really for LivePixel, but it has the capability to understand if somebody is sort of misbehaving. So if it's getting like multiple connections from the same source, ban. If it's getting incorrect data, ban. If it's getting if it's getting data quicker than the rate that I would expect data to be received, ban. And these are permanent bans as well. So it's really, at the moment, I've turned sort of all that off because we've been enjoying playing around with it. It's interesting to see what the capabilities are. And we've had, what was it, last time we did some streams, somebody was putting bad apple on it and things. So, you know, it's been fun to actually see all of that. But in reality, if people start messing about with it, you just want to ban them. That might sound brutal, but I can't really think of a different recourse. We do have the facility to time out as well, if that's the case. So let's go back to... actually, that's kind of true, Morris. It's not really the comms. The ESP is actually pretty crappy at receiving Wi-Fi data. It doesn't receive it in the way I would expect micros to receive it, and the fact that you have absolutely zero control over any hardware timing of it does make things a bit trickier than it should be. What I'm surprised at is clearly the data exists somewhere. So you can't see the display at the moment. I'll just jump over to here. Clearly, you can see it's updating. The data exists somewhere. Where does it exist? Is it on the input buffer of the ESP? Possibly. Is it somewhere in my router? Unlikely. Is it somewhere on the server still waiting to be shoved out of that channel? That could very well possibly be true. There's no doubt some scope for optimization on here, and I think it's because it at the moment it's sort of reading 1 pixel at a time from the Wi-Fi buffer. But I don't think I've got any intention of changing it. I'm just going to ban people that muck about with it. I think that's much better, right? I've got to press the right button. There we go. Right. Yeah, but I've gone off my ESPs now. I think I'm going to replace them with something a bit, well, just better. Right, so have we got this down? Let's just do some quick checks to make sure that things kind of work the way we expect them to. So I just want to make sure we can actually open the file. We need to compile this first. Yeah, I'm not sure. Because it's such a locked down ecosystem for the ESP. I've really sort of no idea where it's putting data, and I think if it let me do some bare metal stuff with it, I could have real live video playing on it. I'm absolutely certain of it. Right, that compile, that's good. So I just want to make sure that we are capable of reading the basics. So can it open the file? Well, it didn't crash, that's good. So let's go to here. If accumulated time is greater than that, then... So one of the things we should do is accumulated time is actually accumulating all of this debug time at the moment, but I'm not too bothered about that. Right, so if we're not at the end of the file, read a line. Read the line in, there we go, 5CF00. So let's get these so that the characters were correct. X was 5, Y was C, R was F, G was 0, B was 0, 2. The characters, by the way. And then we want to draw a pixel with a bunch of hex to ints being called 0, 0, 15, 12, 5. Yeah, that kind of looks good. Right, so with that in mind, we shall start to play some of the history. Let's see what happens. Oh, I remember that little wizard thing being drawn. Oh, Starfree clone, thank you. 41 months, right? I have to get you a special prize. Hey, I think there was some rude pictures there, wasn't there? And this is what we started the stream with when we grabbed the copy of the file. Oh, and it crashed when it got to the end of the thing. Okay. Did we actually... Well, let's just try that again. Let's play it again. But what's actually causing it to crash? It shouldn't be reading anything beyond the end of the file. If it's end of file, if not end of file. Must be trying to read something beyond what it can get. Perhaps the end of the file is not quite a full line. Crashed at Ben. Oh, it's very possible it just sort of read this blank line and fell over. Yeah, that would make some sort of sense. You're trying to access characters that aren't there in the string, so it's thrown the exception. Okay, well, we can put in a check for that, actually. If S-line, I don't know, equals, well, if it's empty. Let's do it properly. If fline.size, sizzle, I like that, is not equal to 5, then break. Oh. Then should we stick in a go-to? If S-line is equal to 5, fine, fine. Why can't we just break from an if? We should be able to break from an if. There we go. Oh, now it's moved all my brackets around again. That's rubbish. Right. It was a little bit slow. I'm just going to speed it up just to see what the damage is. So float f rate equals 0. We'll just double that speed. 0.01, and we'll change that to f rate. Let's have a look. Right, so we'll have a look again. What was the history this time? And then we'll go and grab an update of the history files. It would be nice to put in a pause feature, I think, so we can actually see what some of these rude pictures are. Look at those rude pictures going on. Right. So this is what usually happens when we have the live streams with this, is somebody finds the thing, remembers that they've written a Python script because they're a script kiddie to sort of just spam loads of pixels at it. Let's go and... Oh, put a link in the chat. So if... does Control A and Control I, or is that... I have no idea if it's an Eclipse thing. If there's an empty line at the end, yeah, that's what I think. Exactly, yeah, we just fixed that. So I'm just catching up with some of the things. Right, where are we at with the LivePixel display? Is it still just being spammed with random junk? No, it's not. Well, that's reassuring. But let's draw something in so we've... Oh, is it crashed? Somebody's managed to like sort of send loads of stuff to it. Managed to shut it down. Well, we'll find out actually, see what's going on. Or potentially, I'm actually maybe banned. Yeah, it will do. Well, no, it won't actually. At the moment, I don't think it does. And the reason I think I can't access it is because right now I've got my own thing accessing it, and I've got 2 web browsers accessing it, and one address is only allowed 3 connections to the stuff. So I think that's why. I sent it as 5 uint32s. It's okay. It will just reject anything it's not expecting. It's possible he could have brought it down. I say I've not turned on any of the security features at the moment. But let's go and grab the history file anyway and see, because it'll be nice and big now, I think. Yeah. Now let's go and grab that copy and let's go and bring that back over, and we'll plop it into this one. V. Yeah, look at that. Okay, so we've gone now from 1500 to 700, well, almost 800,000 pixels being sent to it. Let's go and see what that looked like then. Most of this is just going to be sort of noise. So 800,000 at 10 milliseconds per pixel. That's quite a long time. So I think what we need to do is modify our program here to change this if to a while, because we might get stuck into some sort of interesting. We'll just run it to begin with and see what happens. But I think if we were being serious about this, we would change this. So because the frame rate of the application is going to be locked at about 60 hertz, if I sit here, I don't know. Oh, just run it. Just run it. But once every 10 milliseconds, I think, is probably far too slow. So yeah, let's speed this up a bit. The problem is I've got now is the fastest rate it's going to display at is 60 hertz, which is not enough. That's why we need to change this to a while. There we go. So it'll actually draw several pixels per frame. So while accumulate is greater than f rate, subtract that down until there's nothing left. Okay, is that going to work? Ugh, tell I'm half asleep today. There we go. So we get all the pastel shades that got sent to it. So that could be all the noise. There we go. There's the noise. That could be a lot of noise for quite some time. So perhaps we need some sort of indication of how much there is left to do. It's refusing your connections now, is it? Right, well, obviously there's a lot of data being sent there, and most of it's just noise. So maybe we want to go a bit faster, even, and actually see, did anything appear at any point that was useful? So let's go a bit faster. If the rate, so that's 1 pixel per millisecond, 1,000, yes, there will still be 800 seconds to see everything. So we'll just stick an extra 0 in there, go much faster. A lot of data to be looking at. I bet this is streaming well. It's completely hammering my my upload bandwidth. I'm just going to check the. Morris is having his dinner and watching brightly coloured pixels flash very vibrantly. Well, that's boring history, isn't it? So this is the thing. So this is why we put in stuff that if somebody starts to send hundreds and hundreds of pixels within a minute, ban them. Right? It's as simple as that. I think that's what I'll start to switch on for the LivePixel view. So is it down at the moment then? Did somebody bring it down? Did it actually get taken down? Let's have a look. It has, yeah. I don't think it's been taken down, but I've got too many connections open. The video encoding is coping better than it thought. It is It is. Okay, well, one of the things I will check the logs as to why it went down, but I'm not going to do that on stream because it will have the IP address of the offender, because that's unfortunately how it knows who to ban. But in this case, if it has gone down, it's sort of inadvertently banned everybody. So I'll bring that back live after the live stream, I think, because I don't want to put that on screen. The link is, well, it's not going to be very exciting if it is down at the moment. There we go. Yeah, just ban everybody. That's the link to it, but I think it is expired at the moment. In fact, if I pull this up on a different screen, I can have a look at some of the telemetry, sort of without sort of doxing everybody. Yeah, there is one banned address. so I think I can work out who that might be. That's why I want to do this sort of off stream. I'm not going to do that now. And I can also log into the. Well, I'm not going to say who. I don't know who it was. Right? To me, it's just numbers on a screen. But there's one which has caused an offence, and the offence it has caused, according to the logs, is it's sort of like a rate limit contravention. So. Good. Well, this is what we need. Is it star star star? How often is it considered spamming pixels? Yeah, see, that's the thing, right? So I think if a human is using it, probably you're not going to click more than 1 pixel a second, really, or like 20 pixels per second. I don't know. What is legit? But what we want to try and avoid is people sort of saturating it with thousands and thousands of pixels per minute, right? Just trying to run movies to it, which is what people have been doing on the Discord server. So I'm. Did it block? Yeah, it's. It certainly it didn't like that particular address. Yeah. So you got a red flag now. That's it. 1 pixel per second. You can pull off 2 easily. Probably, yeah. I know, but these are the things that we need to sort of to work out. So it's gone into what's more interesting from my perspective is it's banned you, but then decided, yeah, I've had enough. I don't like this. I'm under attack, and gone quiet, gone dark. What is the project about? From Rabulo Snessy? It is, well, it was a LivePixel thing. That it whitelisted that IP and banned the rest. It could have done Pixie. Could have got the logic very wrong. Just have to show a silent movie with 1 frame per second. So we're building something, a history viewer for a like a LivePixel palette thing. I'm just going to jump over to that screen there. So we've got this LED matrix. It's displaying live imagery, or it was until Ben's just brought it down there. Wasn't a rate limit from volume. You'll have to tell me what you sent then. So is it saving all of the pixel changes over time? That's right, yes. So every pixel that gets sent, it's storing them all. And I wanted to build or hack together a quick viewer, and we did that. I mean, that was easy enough to do. Oh, this is now playing very fast, so most of that's going to be noise. So it's not that interesting to actually see. So I'm going to slow that back down again, so we can actually look at the imagery that was sent. So there's not that much, unfortunately. Come on, build. Thank you. You see, I think somebody's creating nice pixel artwork. Somebody's then doing rude pictures. And then this was on it for a bit. And then at the start of tonight, obviously somebody started drawing a gradient. And then Ben got involved. And then this is usually Rogue or Bixie sending gradients like this. Yeah, it is streaming to a real piece of hardware. So that's what this is. So this thing here, or it was, is a LED matrix with a 3D printed thing on the front, acting as a diffuser. That also, I'm going to put on my back wall here, right? Because I think it'll be nice. So during the streams or whenever, people can sort of create their own artwork. And it looks, what's really upsetting though is on the camera, it looks kind of washed out and bleached, but it's really vibrant sat next to it here in person. Even the dark colours look dark, which is good. Right, so I think we'll add some quality of life things to the history viewer. Let's add in a way to sort of speed it up and slow it down and that sort of thing. Some basic stuff. Oh, well, we'll have a little interjection just whilst I'm looking at this. So I was looking at all of this maths for Morris, and it's going to be a video that's coming up because I did notice somebody on the server started to ask questions about projectile motion. What am I doing? Startup project. And I've obviously got a series on YouTube about Code It Yourself worms, and it uses projectile motion in an interesting way, obviously to control the projectiles fired by the worms, but it also does like a reverse projectile sort of transformation. So how do you know what angles and things to aim at? Now, when I made the video series, I actually deferred to a different video. I said, look, this guy can explain it a lot better than I can. And so he walks through the equations. And then I had an idea that actually I want to do something a bit more complicated than that. So I just want to see what state was this video left in. Okay, yeah, let me just set gravity to come back to whatever that mess was in a minute. Let me just set gravity back to normal. There we go. It's compiling. It's compiling. Oh, whilst that's compiling, anybody like that sort of thing? I don't. There we go. Right, so what is this? Well, what I wanted to have was a start and an end point, and it works out the two potential trajectories that you would fire a projectile at according to gravity. So ignore the fact that they can slant all over the place. Of course, this is a parabolic trajectory. Right? So this yellow one is the start, and this blue one is the end. And it can work out the parabolic trajectory required to fire the projectile from the source over here to hit the target. And you can see it works on sort of inclines and things as well. This is not that complicated. The complicated part is deriving the angle at which you should fire at, knowing some other constraints about the scenario, such as the target location, gravity, that sort of thing. And of course, there's always two solutions, so that's why you get an upper and a lower boundary. And I was experimenting with sort of the power that you can fire these things at, and sort of you can sort of backwards, do things backwards, flip things upside down, that sort of thing. To stop it from working. And then what I wanted to sort of factor in was the sort of wind resistance. And that does actually make things a lot more complicated. Well, at least at first I thought it did. And that's when I started trawling through all of this maths to try and derive the equations for wind resistance. Because one of the things, if I'm going to make a video about it, I don't like doing videos where I just sort of go, right, that is what it is, just ignore it. I'd like to sort of walk people through why things are the way they are. And you can see I was trucking through all of this maths and got to the end, and basically you solve it. You solve quite a complicated quadratic equation where instead of solving for x squared, you're solving for tan squared of theta. Right? The rules are all the same stuff you learnt in high school. And that's exactly what it's doing in order to work out where things are. But then I thought, what's going on with wind resistance? And that really throws a spanner in the works, because no longer is the trajectory parabolic. Well, at least I thought that was the case, but it turns out actually it might well be. Ah, desk cam. Yeah, you're right. Oh dear. Sorry about that. People are going to have to keep reminding me. Thank you, Londo. Can we rewind? Right, let me go back a little bit then. I shall go back. You didn't see any of the demo running then, did you? Oh dear me. Right. Right, none of that happened. Let's go back. Thank you, Morris. Oh dear. Right, good. We can start to see the screen again. So, start again. There was a bloke or somebody on the Discord server that was interested in projectile motion, and I've done that before. So I wanted to create a little application to experiment with projectile motion, and here we can see, now you can see at least, the two sort of parabolic solutions that are required to solve a projectile motion problem. And the idea is you can specify a start, the yellow dot, and you can specify an end, the blue dot. And it gives you the two possible solutions. There's always going to be two solutions. And I can change sort of the energy at which the projectile is fired. Naturally, as you get to the same or the lowest amount of energy required, you sort of go towards 45 degrees, which is the provable optimal trajectory for sort of hitting a target somewhere. See? There we go. That's sort of the most optimal solution there. And this is all very well and good, and I was playing with the maths on this to sort of derive it all, because that's what I like to do. I actually quite enjoy doing this, but as I mentioned, now you can see the maths on the screen. You're not solving it for x squared, you're solving it for tan squared of theta, but it's just the same. But it does make the maths a bit of a mouthful. And then I wanted to throw in wind resistance, and I was quite convinced that wind resistance is complicated because it's not parabolic. But I think it is, and that's what I'm currently exploring at the moment. So this is really all I'm going with this, is if I treat wind resistance as a version of gravity, so we no longer have gravity sort of vertically down the screen. So there we go. So this has got a strong sort of wind resistance going in. How do I angle the shot in order to hit the target? With this wind resistance factored in. And at the moment it's just plotting the trajectory with wind resistance. It's not actually trying to calculate the target, it's calculating it for an ideal scenario. But what occurred to me, which surprised me, is actually wind resistance is also parabolic, but it's parabolic rotated around sort of the perpendicular to gravity, really. So of course when you treat it as gravity just with a single dimension like this going down, that's why the equations were so simple. But I thought, well, if we factor in both axes, actually it becomes really complicated to solve. But I think it doesn't. If we just sort of pre-rotate the scene, I think there's a way to calculate the parabolic trajectory required to get from start to end without needing to do lots of nasty maths. So that's something I'm currently working on at the moment. Anyway. So yeah, sorry that I was on the wrong camera there. I definitely need something on the screen that tells me what camera I'm currently using. Would this work better as a pair of parametric equations? Well, yeah, kind of. It kind of is a pair of parametric equations. Quadratic to speed. Maybe I'm banned. What's going on? Would work better. Oh, hang on. So my Twitch chat has moved around. Yeah, exactly. I know we can go down the absolute what is the physics realistic route of a projectile here, and I'm not interested in that as a solution. I'm interested more in the worms approach, right? So I have played games of Worms where the AI is quite happily capable of getting the projectile to fire around corners because it exploits the wind to its advantage, as do the good players. And I think that's why I can get away with just doing this sort of rotation pre-calculation of all of this. So hopefully this will make its way into a video fairly soon, because I think I'm at the end of it now. I think I've got it to work. And I just need to update the little program here, and I'm going to stick it into PG Tinker and all that sort of thing and try to make it work. What else have I been working on? Well, one of them is this. Maybe this might... Let's see where this works. Set as startup project. So I've posted a few of these videos on the Discord server already. I just want to make sure that I'm loading the right thing here and drawing the right thing. Let's just see. I can't remember where this was up to, so it might not be what I expect it to be when it starts up. So I put out a video and a quick tweet. Yeah, there we go. About let's see if we can do something about that frame rate. Why are we so slow? Shouldn't be that slow. I think I'm trying to do something clever. See, it's the problem with trying to launch a program in the middle of sort of working on it. Right, yeah. So what's this mess then? I'm just backing out of it a little bit here. There we go. So one of the things that it occurred to me I could do. Let's get back out a little bit more. That texture's rubbish. That texture was sent to me by Luby, and it does me no favours in trying to explain what's actually going on here. I just wanted him to see the artwork. Does that not give me a file? Does Visual Studio not give me sort of files yet? I can't remember what it was called. Is it clay.png? I can't remember. Yes, it was. Okay. Compiles are slow tonight. What's going on? Right. Let's go this way and rotate a bit. You can see it's a complete and utter mess at the moment. Right? Let me just change a value to stop this from being a complete and utter mess, and that way we can understand what's actually being shown here. I just want to introduce this clipping that I've taken out. That one and that one. Yeah. I think that's all of the clipping I need to take out. That should just make things a little bit more sane. Oh, build errors, what's going on? Missing, oh. Are we getting to the point where we're asking what the airspeed velocity... right, oh, still fail, what? No, that can't... Did it still fail? Oh, it did still fail. Why does it fail? Syntax error, missing... No, hang on. That just didn't compile, did it? I'm not clicking well tonight. Must be the new glasses. That's no good, is it? If I'm misclicking on things. Right, there we go. Okay, what's going on here? Now, ignore the pop in and pop out. If you didn't know, Pixel Game Engine has a function called Draw Warped Decal, and it was used to some effect in a video called Orthogonal Projections of Dungeon Warping, where we basically did sort of a 2D scene, but it was represented somewhat three-dimensionally, but we could make it look 2D from any angle. That's what the orthographic projection does. One of the things I've always wanted to do is, well, there's no reason why you can't use a perspective transformation either to actually draw quads. Now, why are they quads and not triangles? Well, it's a peculiarity of the feature of Draw Warped Decal, that it's doing the texture perspective calculations as part of rendering. So I don't actually need to pass any of that through. It kind of just happens automatically. The downside is there was no depth buffer, so you had to manually sort absolutely everything, which is a nightmare in 3D, particularly when you've got complex scenes such as this one. You've got lots of things overlapping each other. You really do need a depth buffer in hardware, and Pixel Game Engine actually had one. It was one of these sort of hidden secret features which I never really told anybody about, but there was a couple of functions in the header file which allowed you to work with a depth buffer. And I thought, well, maybe it's time to play with that a little bit more and sort of demonstrate this capability. So I think there'll be a video about this too. Now, of course, when people see multiple cubes on a screen, they get very excited about potential applications. I wouldn't be jumping up and down being too happy just yet. This is a hack. Firstly, it's not the optimal way to draw cubes in the slightest, but it's a nice way to sort of hack 3D graphics into the Pixel Game Engine. You can also do lighting, of course, because you can shade the quads with the tinting, so that's something else we can look at. I'm just trying to think where I'm going with this. My sort of use case for this was going to be implementing the first-person shooter again, but this time in sort of to finish off that quadrilogy of videos. So each video presented a slightly different way of doing it, and we can finish off with sort of a far more proactive 3D scene. And wrap up some of the functions. Anyway, if you wanted to go and play with the decal, so the depth buffer stuff, it's actually already there in the Pixel game engine that's up and running. You just need to enable. Let me show you where we enable this. It is unsupported at the moment, so keep that in mind. Hang on, there's my quad renderer. But if you enable experimental features before you include Pixel Game Engine, that does actually enable a handful of functions. That's fine. The one that we're interested in here is this lightweight 3D draw warped decal, where you pass in. Well, you do need to pass in three-dimensional coordinates. So that suddenly takes OLC, VFD, 2D out of the equation. You have to have something else. And you're probably going to need your own matrix implementations. They do kind of exist in the graphics 3D extension, but I've not used those. I've used something else. And the critical one is this one, clear buffer, which you don't need to have that enabled. But this true, for example, calls clear the back buffer. So there we go. So some interesting features there. Yeah. Does Jared have new glasses? Yes, I do. Yes. One lone craft. Yeah, I'm not interested in cube-based games. Radiance cascades. Everybody's on about Radiance cascades at the moment. I don't know why. I don't think they're that cool. Lots of post-processing possibility. Yeah, that's why I think there's some real interesting things we can do. Don't forget, you can also update decals in real time too. So I think there's some interesting portal effects you could get out of this. Need to think about it. Anyway, my hour is up. My voice is disappearing. So thank you all for watching. Sorry about the mixed up camera for a little bit. Ben, I'm going to hunt you down for crashing my LivePixel server. And with that, I wish you all the best. Until next time, see you later.